Handling really large data sets can be a big challenge for data engineers. In this video, I want to show you how to efficiently load, partition, and analyze New York City taxi data using KDB+, Parquet files, and the Arrow KDB interface. And you can check out the blog linked below for all of the code I'm going to show. So to follow along, you'll need a few things. First, KDB+ installed, which you can simply download for free from kx.com. Secondly, you'll need to install the open source Arrow KDB library, and that's on GitHub. And thirdly, the New York City taxi dataset, which is available in Parquet format. And I'm going to grab files from June to September, but you can take as many as you want. And links for everything and their installation instructions are in the description. So I have a KDB instance already running, and I am using the VS Code extension from KX here. So if you want to install and execute a Q script like me on VS Code, you can just download that. So I have that ready to go. I'm going to start by loading in my script that we got from GitHub into my instance. Then I'm going to use the API here, which is read Parquet row groups to table, and that's going to give me a number of rows. I'm using the count function here as well to grab the number of rows. So we've got about 3.5 million rows in one file. So partitioning is going to be a good idea to efficiently manage and query data of this size. And partitioning works by organizing data into chunks so that queries only scan the relevant portions that you filtered for. So for this data set, I'm going to say we'll partition by month. But if our data grew to, say, millions of rows per day, we could go further and partition by day or even by hour, depending on the size and the growth rate of your data set. Now, in order to save our data down, we're going to create a few helper functions to make that easier. So one is to parse the month from the file name so that we can use it. And we have a function here written in the Q language called parse month. And I want to just pause here, and for anyone maybe new to the Q language and syntax, I do just want to break this down. So first thing to note here is in KDB, we are executing right to left, meaning the first chunk to be executed will be on the right hand side of this lambda function here. So I'm going to just define my files above. I am just going to say, take the first one and define that to the word file. That's what I've used in my function here as my parameter. So we're just going to do the first one for demonstration purposes. And then the first piece here on the right hand side is making use of the SSR function, which stands for string search and replace. So it does what it sounds like. It's going to search each of my file names, and anywhere it finds a hyphen, it's going to replace it with a full stop. And that was important for this month piece here, because in KDB month and other temporal data types are separated with full stops. So next we use the VS function, which stands for vector from scalar, and it lets us split something into many parts based on the argument defined on the left of it. So if we just highlight all this piece now and execute that, you'll see we now have split that up into 3 separate things. And I'm only interested in the last one because that's got the month in it, and that's what we're looking for. So we'll run that. And then of this, we only need the first part of this. We don't need the word Parquet. So you could use VS again and split on full stop and take the first 2. But actually, maybe a faster way is just using the take operator, which is 7 hash. So 7 because I want to just get the first 7 characters. And we're nearly there now. This is our month, but the only thing left to do is change the data type. So the data type here is a string. We can see that with the commas that are surrounding it. So I'm going to just use the cast operator with M, and that changes it to a month. If you're not sure on what data types are which or how to tell, we have the reference card here on the documentation, which is really handy. So you can look for the data type you're looking for, which for me it was month. And then you can see on the left hand side the letter M, and that's how I knew I need to pass it an M in order to cast it or change it. Okay, there we have the month extracted as the right data type from the file name. So I did cover a few concepts there, and if you found it interesting and you think you might want to see more of the Q language, I am going to link below to our free Academy modules that teach all about string manipulation like this and casting between different data types. So I'll just execute all of this now to define everything. Next, let's actually read in our file using the read Parquet to table API. So I'm going to just define it as T. I'm going to run this line here inside the function just to take a look at it in my output. So you can see we have our data loaded in. And I want to inspect this a little bit before I save it down. So I'm just going to run this line, which I have commented out, which is counting the number of rows by the drop-off time column. And I'm indexing in just to get the month out of that. And we can see what kind of dates and what kind of months we have in the data set. And I wanted to do that just because we are going to partition by month, so it's good to have a look in the file to see what you have. So I can see I have mostly rows for the correct month, which was June. That was in the file name, but I do have a few extras before and after. So I'm going to decide to clean them up, and I remove them here in this line in my function. I'd rather just have actual exact days for the analysis I'm going to do. So now I'm happy with this table. It's worth noting if you wanted to do more changes, like maybe your data types, you could just have a look at the data types saying using the meta command. And you can see here, you get the data types back. Again, you can use the reference card to look up what they are. And if you wanted to change something, say changing a float here, you might want to make that a real, which is less precision, but might be fine for your data set, and it would improve the storage needs. Then you could make that call at this point. So doing some analysis to figure out, are these the right data types, is a good idea. The Arrow KDB interface will infer them automatically from Arrow to KDB, which is really handy. But obviously if you want to change any of those, you can do so at this point. And you can do that using cast, which we've seen in the previous function with that $ operator. Now I'm happy with this table to go to disk as it is, so I'm going to do that next. So we have a function here, save file, and I'm using my parse month and read file we just created. And then I'm using this .q.dpft, which is an inbuilt function in KDB. And it's a really nice, easy way to save each table, partition by whatever you want, whether it be month, day, hour, etc. And we're going to use the month, which is the second variable here. The first variable here is going to be where you want to save it. So I've just set up a data directory. Now we are also setting an attribute on the vendor ID column here, and that's all about improving performance. But I'm going to link to a different video below that shows you how to choose the right attribute and tells you more about them in detail. And then obviously I'm passing the table as the last parameter. So if we execute all of this, and then we can run this function using each, and that's going to loop over each of our files and save them down month by month. So once this is complete, it's just returned the name of the 3 tables it's saved down back. We know it's ready to query. So we're going to load it into memory, and that will allow us to query all of those months. So I'm going to first just query the number of rows by month, and you can see here we have the 3 dates there. And you might notice I'm using this month column, whereas before we had to index in on the date drop-off time column. But that's one thing to note about partitioning. Whatever you've partitioned on, which for us was month, that will get added in the partitioning step. And I want to point out now that when you're querying a large partition database, it's really important to include that partition or column, so for us it's month, as the first constraint when you have a where clause. So that speeds up queries, as KDB Plus is only going to search through the months or partitions as opposed to all of them. And that's kind of the whole point of partitioning your data in the first place. In my examples here, I'm actually aggregating across all partitions. I'm not passing a where constraint here. If I wasn't aggregating, as in I'm summing here and I'm grouping by, this would not be wise to do without using a where clause with the month there. So let's do a few aggregations here, and we're going to sum up some of the columns and then just do a count of the rows. And we're going to do this by date. So you can see how quick that was to query over those 9 million rows over 3 months. So that's your data loaded in and converted down to disk in our partitioned database. So for Python lovers, I want to show you querying the same database using Parquet, which is our Python interface for KDB+. So if you prefer running your queries in Python or pandas-like syntax, we have a query API for that. So let me jump to a Jupyter Notebook to do that. First, I'm going to import Parquet, and then I map the partition database, so pointing it to the same path where we just saved that data down. And that's going to make it available to Parquet to query. Next, I'm going to run another aggregation query, this time grouping by hourly amounts instead of days. Cool, so we've got our hourly amounts back. So finally, I want to plot those hourly amounts, and I can use something like Plotly, and I'm going to use matplotlib here just to see how that data looks during the day. So we convert the table to a pandas data frame for easy plotting, and we can see now that this data is saying while the number of taxi trips in orange on the bottom is steady, the fare and the tip amounts do increase a lot in the afternoon and in the early evening. So probably saying that you've got longer trips then, and obviously higher demand as well. So that's it for this video. I hope you can see how quick and easy it is to get your Parquet files into KDB Plus, to get partitioning that data, querying it, and then visualizing with either Q or also Python. So I hope you find this helpful, and to try it yourself, remember you can just sign up for the KDB Plus free trial on kx.com. And if you have any questions, you can join the KX community on Slack, where we can help you and chat to you over there.